Good morning, sir.
Good morning, sir. Good morning, sir.
Bem, sir. Bem, sir. Hello, class. Hello. Hello.
Morning, sir.
Good morning, sir.
Good morning,
Morning, sir.
everybody. How was your night? That's family. That's everything. And that's preparation for. I was told that you guys are preparing for. What do you call it?
Yeah.
It depends. Okay. So, so my surveyors. A word of advice: do what you can and leave the rest. I'll be when so. Uh, I'm setting your exam question. So by end of the day, I will really send it. And in the last course that I took, that is SVG 405, people failed the course. And why they failed the course was because they failed to submit any assignment. And it's not because it's supposed to follow any assignment. Even the quiz that I give, they failed to submit. With the and evidence showed that in the attendance, they didn't attend the class. So they got five. Someone got five in the exam. Someone even got like five in the exam. So I was thinking that okay, we did CAO, maybe we can push him and he can get D and go away. The guy actually decided to fail himself. So up to now, I've not seen your lab. I've given four assignments, even five upper. I've not seen anything. It will be I will be powerless if I cannot. I can powerless to help you if you don't have any assignment. If you don't have any quiz, I will be powerless to help you. So I want everybody to pass because I'm also a student like you. I'm under Professor Lele that's supposed to take the course. So I told you from the beginning, I'm a student like you. So I won't want you to fail because school fees is not expensive. Have they not increased your school fees?
I've been crazy.
They are increased it. So you can imagine having to spend under school fees because of one course like that. Yes, one course that is not that's not jawing yet. I want to delay you. So don't delay yourself. Manage your time. I know it's not easy. Having so many having so many courses to do, project depends and everything to do. But you can manage your time. Our advice is not to sleep for 3 days and do what you can do. And know that you are doing once in a lifetime. It's not. It's not once in a lifetime.
It is.
It is, Abi. So once in a lifetime. Don't let your own be true in a lifetime. Oh, okay, sorry everybody. 1 minute, please. I'm very sorry for the interruption. So please try and possible and do your assignment and do your lab so that you can have a record to assist you in the exam should in case you have exam tension. I know they want to rush you and you may have 2 exams in a day. So imagine having 2 exams in a day and not just 2 exams, 2 exams in a day. You know what that means. So are we together? Hello,
We
am I
are
talking to
together,
myself?
sir. We are together, sir.
Anyway,
Yes, sir, we are together.
so Ada, you are there, Abi?
Yes, sir, yes, sir.
We are with you, sir.
Okay, so let's start proper. Now, today's lecture is on the database modeling. Normally, we have actually undergone the study of database itself and database modeling proper. Now, the one that concerns us as geomatics engineers and surveyors is the database. And I'm sure you guys have come across the database before now. Yes or no? Yes or
Yes,
no? Have you not come across the database? Hello, class. Hello.
Yes, sir. Hello, sir.
This is your first time of coming or hearing of the database.
No, sir.
And have you while you are used to ArcGIS or QGIS, have you used the database for anything at all?
Yes, sir.
Hello, you have used database for some things, Abi?
Yes,
Abi?
sir. Yes,
Good.
sir.
So, but do you know the meaning of can you define a database? Can you actually define a database? Can you define it? Can someone define it for me? Okay, no problem. Let's go forward. So at the end of the lecture, each student is able to be able to describe and explain the concept of the database in details, not just database, and that's all. You are supposed to know the integrity of a geodatabase. If you hear what geodatabase, you know it. You should be able to identify and list all types of geodatabase. Three, you should be able to enumerate or list the component of a geodatabase. Four, you should be able to actually detail the architecture of a geodatabase, how a geodatabase looks like. Five, you should be able to describe the following concept in a geodatabase. When you say what's the table, we refer to a database. What's the feature class? What's the feature? What's the attribute data type? You should be able to define it. I know I give an assignment on access database design and programming, and you have not submitted. Nobody has submitted to. I know. So, but no problem. Let's continue. So, welcome to the class.
Sorry, sir. Hello, sir. Hello, sir. Hi, please, can anyone hear me?
You know.
Okay. Please, did Soviet Tosin say we've not submitted the assignment?
Hello?
Okay, hello,
Sorry.
sir.
Yes, you are saying something.
Yes, I was asking, you said something about the assignment, the Microsoft.
Yes. Microsoft Access should do. You create a database of your class and your department, even
Yes, sir.
classroom and lecturer and courses. And I've not seen it up to now.
Sir, I sent it to you. I've sent it to you. I sent it to your mail. Yes, sir.
Remind me. Sent to my mail. You sent to my mail.
Yes.
Send to my WhatsApp.
Yes,
Send
sir.
to my WhatsApp. Send to my WhatsApp. So that I can be sure that I have 2 copies. If I didn't find that in the mail, I should be able to find in WhatsApp. So
Okay, sir.
continuing. So let's continue. Now the question will now be, what's a geodatabase? A geodatabase is a collection of geographic data sets organized to facilitate the sharing and the use of geographic information. Basically, we could have called it a geospatial database or geospatial database. But because we are in geography, we are geospatial engineers, and geographers also are concerned, and they are the ones that come up before the advent of geospatial. We are being exposed to geographic information system before geospatial information system. So that is why we are still the concept of geographic data set. Now, database, just as I have said, when you tell that the database is just a collection of related data, the same thing goes for a geodatabase. The geo comes to justify why is the geographic data set. So a collection of geographic data sets organized to facilitate sharing and use of geographic information. It serves as a structured repository for storing and managing spatial data. Now, you have spatial data, like you have a land parcel, you have a raster image of the land parcel, you have the record of the owner, you have the tax record, you have the land use, land cover area of the place. How do you store these things? Thank God that you guys have been exposed to land use, land cover mapping. remote sensing. You have been exposed to photogrammetry. You're supposed to be exposed to cadastral survey. You have been exposed to hydrography. So many subsets of and categories of surveying you have been exposed to. So that means that you can capture information about the Earth in different methods, in different ways, and of different nature. Then how do you now organize them such that you can easily pick object of interest, information of interest, without having to do with the whole lot of unnecessary information or unnecessary details I don't need at the time. Imagine as a garbage collector, I just need information about the address of the house. And address of the house is also a special information. So I'm not interested because I'm a garbage collector. I'm not interested about the owner of the house. I'm not interested about the size of the house. My interest is just because the address to pick it up and the volume of the garbage of the refuse or the waste they are produced. So I'll know how to carry it and move it to my place. I also knew the direction to the path to the house I'm interested in. So as a result, we need to create a system where this information that are being gathered together via different means and of different nature can be accessed by respective users. We have users that are of vast clientele. We have the government user, we have the private users, which are the commercial service providers. Even the NEPAs now, the electricity distributors, the eco-electric. I don't know, is it Ibadan this code? Is it Ibadan school like that's covering your site? Hello, guys. Hello.
Hello, sir.
Hello. Is
Yes,
it
sir.
Ibadan
Hello,
this
sir.
code that is covering your site? I'm asking a question.
I can't
No
get you,
response.
sir.
You know, we have
Sir, we don't
electricity.
know.
We
Yeah,
don't
I don't
know.
know.
So,
Yes, sir.
as a surveyor, year 5, student of student that you have been exposed to GIS, you don't know the electricity distributor that is covering your own area of land. How do you pay NEPA bill? Eh? You're supposed to know now. At least because these informations are also geospatial information. Maybe maybe you have to change your lab to geospatial information. Because anyway, that being said, what we are trying to say in short is that we need a database system that can handle special information. So such a database will now be called a geodatabase. So everybody can store information about natural and man-made features on the Earth's surface, such as addresses, as I've said before, road network, park, boundaries, and more. So that being said, you know what the geodatabase is all about. Now, a quick one as well, they can ask you what are the type of geodatabase that you have espoused to. Okay, man. So as this course is concerned, we are not going to deep depth into more of these types, but you are expected to know the types beforehand. We have the 5 base database, where all your database or the database can be stored, can be saved as a directory in the computer or on the disk. You can have your file database on your flash drive, and you can use that to disseminate your information as the way you want it. Also, we have what we call an enterprise database. Being an enterprise database, you know, unlike file that can be moved around and that can be a single user, that can be saved in a site in a flash or in a directory. The enterprise database is like a multi-user relational database system that supports concurrent editing and data management. Have you guys do anything like Mapathon? Hello, class.
No, sir, I've not done it.
No, sir. No,
Okay.
sir.
So there is a community called OSM, OpenStreetMap. Have you heard of OpenStreetMap?
Yes, sir.
Yes, sir.
Have you heard of OpenStreetMap? Hello,
Yes, sir.
class.
Yes, sir.
We've had.
I'm not talking to myself.
We've heard of it,
Yes,
sir.
sir.
Hello.
Yes, sir. We've heard of it,
Hello?
sir.
Sir, we.
Hello, sir. We're answering
We
you,
Hello,
can
sir.
hear
sir.
you. We said we've heard of it.
Okay. So in OpenStreetMap, there is what you call an enterprise database, such that just like a person is viewing the database, another person can actually be editing it. Remember, we talk about the database that give access to editing, updating, and view. If you remember, we talk about multi-views, where you can actually view under external model, where you can actually view, and when under internal model, you can also view and edit. So you have your enterprise database give that support, such that as you are editing the shape files, editing your database, it will not distort the data management system. So that's what we call an enterprise database. Now we also have what we call a personal geodatabase or mobile geodatabase. It's a geodatabase system that is being managed by Microsoft Access. The Microsoft Access based database for single users is a personal system, PC. So PCs are made by Microsoft, and as a result, they are the ones that now try to dominate or monopolize the word personal. So we also have what you call the specialized database. It's one of the least heavyweights and is the least weight what you call the lightweight is a lightweight database. It's a lightweight database. It's a lightweight database. So it's one that can be managed using an SQLite database engine. So we're still going to come across what they call an SQLite. So that specialized got it from an SQLite database engine. Going further, we have components of a database. A database cannot function or is actually has some component that makes up the database. These functions are very vital. Without it, a database cannot be called a database. So what make up a database include what we call the feature class. The feature classes is just a representation of the geographic features. If you look at the animation and on your right hand side, you can see that we have points, we have line, we have polygon, and we have raster. So about these rasters, what makes this one a database? Because that's what you call feature class, which are the points, the lines, and the polygons that make up what they call the feature class. And they are the ones that are being used to represent geographic features. Then we have the raster data set, which is the continuous image. Now we have the store images. We have raster images, large cover images, geo-based, geotag images. So you combine together with the table. Now these tables are the ones that contain non-spatial attributes. Remember, for those of you that are versatile with shapefile, if you create a shapefile in ArcGIS or ArcPro or QGIS, it will accompany you with 3 things. It will accompany with the shape of the file shape. If you want to open a shapefile in AutoCAD, you will see some .dwg. Yes or no?
Yes, sir.
That is the feature class. Accompanying that feature class, you will also see a BDL. Yes or no?
Yes, sir.
That's the table. That's the database that represents the table. And finally, you now see some some I don't know, most of the time it doesn't come with it most of the time, but there are some extensions that actually hold in the rasters. But for shapefiles, they don't have the raster data set. But for a geodatabase, it has an extension for the raster files. So as a result, these three are the main or the fundamental component of the database. However, a database still has three other components that complete it. You know, if we said a family, in a family, there must be husband and wife, yes or no?
Yes, sir.
Yes, sir.
Is a child a must?
Not at all,
Yes,
sir.
sir.
No, hey. So a family must a family unit must make up of husband and wife. So as a result, those are the fundamental components of the family. And the fundamental components of a geodatabase are the feature class, the raster data set, and the tables. Good morning. Yeah, I don't know. So, however, the other components that are not the fundamental one, but they are the complete one, that is called the relationship class, which defines the association between feature class, the domain, which specify valid attributes. You know, the domain. Imagine someone telling me that, oh, in Futao, we have Lekki Lagoon. Is it possible? You have Lekki Lagoon in Futa. That's not what is responding.
No, sir.
No. So domains means the specified valid attribute of a valid attribute values. So you can't just give a river point position because it's a continuous is a line. Abi, you cannot just give a mile point starting point and end point because it's a point feature. So we have what we call valid attribute values. Those are the what we call domains. Then we have topology. Topology now talk about special relationship and rules. You guys have done GIS now. GIS 1 and 2 or so. Yes or no?
You've done it,
Yes,
sir.
sir.
You have done GIS. And in
Yes.
GIS, we have taught you topologies. Yes or no?
Huh?
They taught you
Yes, sir.
topology.
We
They
did
taught you
topology.
topology. So topology is part of a geodatabase. One of the components of a geodatabase, but it's not the fundamental component. So moving further. Then now let's go to what they call the architecture of a database. Now, you know what you call architecture? How is it being formed? What are the structure? How does it look like? Now, a database storage model is based on a series of simple but yet essential relational database concepts and leverage the strength underlying your database management systems. Just as I've said that a database tries to store information, Abi, for easy editing, manipulating, and viewing, as well as updating. These principles of database management system is being used by what they call the geodatabase itself as well. Because for a database to work, there must be a database management system that allows us to actually view that database, that allows us to actually edit that database, that allows us also to update that database. So the best rule there, when we talk about component of a geodatabase, of which a table is a fundamental component, then the architecture of a database now makes use of simple tables and well-defined attribute types to store schema, rules, basis, and special attributes for each geographic data set. Each geographic data set, be it points, be it polygons, be it lines, be it multi-patch, be it raster files, all have accompanying our spatial data sets. And this will say they have what we call this descriptive data sets accompanying them. We'll talk about metadata accompanying them as well. How do you manage these things? You are managing a table. And as a result, this architecture of a database is such that there's a simple table and a well-defined attribute types. That this will say a table has a data type that are being used to actually maintain this architecture for it to work. Now, apart from those two things I talk about, talk about two things before now. The power, the underlying principle of a DBMS, and the simplicity of a table. The last thing is the combination of the principles underlying a DBMS and the simplicity of a table give room to what you call a structured query language that can now be used to create, modify query tables and their data elements. You know, we are talking about architecture of a database. I want to talk about how a database works. The skeleton on which a database is being formed. The skeleton on which a database is being formed is just that it's leveraging on the fact that there's a database system that handles the viewing, the manipulation, the updating, the storage, and so on. It also undercuts the idea of the simplicity of a table. Now, what do I mean by a table? The table is the simple, most used database model. Or we can call it a relation. Don't forget, a relation. A relation. Now, going further, being a relation, they are so simple and so easy that they can store both spatial and unspatial data. Not in a table. You can put a name of a person there. You can put the address of a person there. You can put X, Y, and Z coordinates there. Yes or no? The answer is yes, if you don't want to answer. So the last thing that now complement or cement the principle of a DBMS and the simplicity of a table is the structured query language. With this structured query language, we can create, modify, and query tables. Not only that, or not only tables, even the elements or the instance in the table. I hope SQL is not new to you. Hello, class.
No, sir.
I hope you can all use my SQL very well.
No, sir. No, sir.
No.
Okay. But you know of my SQL, right?
Yes, sir, we do.
So it's just a programming language that's
Yes.
work based on SQL. That is a structured query language where you can use it to actually create, modify, and query tables. I can sure that if you have done my assignment on ArcGIS Pro, there's a part where we are asked to query based on location. You are asked to query based on can query based on attributes, you can query based on location, you can be query based on relationship. Yes or no? For those of you that are used to have GIS, you can query or you can select a feature based on its attribute. Yes or no?
Yes, sir.
Yes, sir.
What it uses is an SQL. It uses a social query language to work. Now, don't forget that we have talked about three things that actually makes a geodatabase to work. Now, a database itself have now become what I call an object, or a database is now an object relational database. What do you mean by object relational database? Remember, we talk about entity relationship model. Another name for an entity relationship model is called object relationship model. Meaning that each data set becomes an object, and that can be described using a table. I can say that, okay, in your school, there's an object called student. This student can be described using a table where we have name of students, particular number of students, payment of students, cost or program. Yes or no? Yes or
sir.
no? The same thing goes for shape files or feature class or raster images. A raster image is an object. This object can be described using a table or relational database, relational table relation. Where for that raster table, for that raster, we may have the land use, the pixel, the resolution, the pixel count, the pixel class. At least you guys have done what you call it. You have done land use and cover now. When you are asked to find the area covered by wetland, either covered by land, bare land, you can find that you can create a table for those land classes. Yes or no?
Yes, sir.
So that's what we are saying. That a geodatabase is an object that can exist, as low in DBMS table. If these tables have identities, behaviors are supplied based on the application logic. Now, geodatabase storage. No, we're talking about how it works. We'll talk about that. So, in the architecture of a geodatabase, there must be the DBMS. There must be a table. There must be a structural query language, and this makes the database a relational, an object relation model. Now, how do we store our relational model? Geodatabase model. Our geodatabase model is being stored using relational databases. Meaning that at the core of the geodatabase is a standard relational database schema. I hope you can see, remember what we call a schema. Class.
Very well.
Yeah. So these things will come out in the exam. They will ask you what the schema, a database schema. You're on your own. If don't know, go and revise. So what we are saying that even for you to know that you are a student of the database modeling and design is because you'll be talking about some languages. Imagine you see a person talking about Allah, talking about Sida, talking about you see a person, he's talking about Allah, talking about Sila, talking about Muhammad, he's talking about Wasi, Wasi, he's talking about hijab, he's talking about this Tesba. What do you think the person is? Can you tell what person? You can actually tell us who the person is? Yes or no?
Yes, sir.
A Muslim.
This is a Muslim.
Muslim. Beautiful. The same thing goes for a student of database modeling and design. there are some words, there are some jargons you have to know. You expect to know. Of which schema is one of it. Database is one of it. Relational is one of it. If I talk about relation, if I talk about tables, if I talk about tuples, if I talk about columns, if I talk about fields, if I talk about database, if I talk about Oracle, DBMS, Postgres, then they will know that you are a student of what, or you are an expert in what? Database management systems. Are we together?
Yes, sir.
So what we are saying is that at the core cost of a geodatabase, before we can save or store our geodatabase, we need what we call a standard relational database schema. Meaning that we must have a relational database model, which is in summary, they are just what? They are just tables. These tables can be stored on file as files on a disk. If they are stored on file on a disk, they become what we call a file-based database. Abi?
Yes, sir.
They can be stored in DBMS like Oracle, IBM DB2, Postgres SQL, Microsoft SQL Server, that's where we have the MS MySQL and so on. So if they are being stored in this DBMS, depending on the DBMS that they used, it can now be a specialized database, or it can be a what? A personal database, or it can be a what? An enterprise database. Are we together?
Yes, sir.
I hope you understood I hope you understood where I'm driving at. When you're talking about the content, when we're talking about the storage type or storage system for your databases, then we are actually talking about types of your database. So depending on the way they are being stored, you can know the type of database you are talking about. If they are being stored as a file on a disk, they become file-based database. They are file database. If they are being moved to any DBMS system, be it Oracle, be it Microsoft Access, be it Microsoft SQL, then they can now actually be an enterprise database, or they can be a personal database, or they can be a specialized database. They become personal if they are what Microsoft Access based. They become enterprise if you are using something like if I use database system like an Oracle or IBM, Postgres SQL, and other variant of or dialects of SQL. Let's move away from there. The fundamentals of what? The fundamentals of database. I've come across it before. I've said this. I've actually talked about these fundamentals before now, which involve the fundamental data set in the database, involve the feature class, the data set, and the tables. I've told you that these three things are the ones that make up a database. The table is not a collection of rows, each containing the same field. That's the table. When you join a table, you will see that we have rows and we have fixed number of numbers of columns, which are also called the rows, the code on the fields. Then we have the feature class. What feature class is talking about the graphical or geographic representation of graphical representation of geographic features using points, lines, polygon geometries for geographic features, where each of those is a feature. Then we have data set containing rasters, which may be continuous geographic data phenomenon. On rasters, you can talk about slope. A slope, talking about the contour. I'm talking about the watershed, I'm talking about the rainfall. No rainfall pattern. It's not single point. It's a continuous. No. We're talking about water flow and the rest. Talk about database storage in tables and files, which I've said before that database storage includes both the schemas and the rule base for geographic data sets for simple tabular storage of the spatial and attribute data. What are they saying? What they're saying here is that even though we are using tables to store our database, the tables will not only include just the databases, that just data alone. It also includes some rules that will dictate how these tables relate to one another. You know, when you have a database or database for buildings in your school, you want to tell us that this building is inside Unilag. This building is inside faculty of arts. This building is this department is inside this faculty is inside this university. Yes or no?
Yes, sir.
So these informations will also be stored in a table. That's why we're saying that a table will not only contain the schema, it will also contain the rules for which you can add and subtract and view and select your data. So now let's move further into the fundamentals of the database. We know that the fundamentals of the database includes a table, which is the simplest way for us to store our database, a table. Now, this table, what's the table in the lingua of your database? No, don't forget that table is not the same in a database system. A table in a database system is different from a table in a database. Let that one be behind your mind, so that an accountant, an accountant. Yes or no?
Sir.
An accountant. You accuse the question of an accountant.
Yes, sir. Calculate figures.
Document record, Abi. You document record financial transactions. Won't you not use the database?
It will.
It will. Won't you not know have knowledge about the table?
It will.
Good. But we have the basics of a database?
Never, sir.
Never. Now we not tell that the same table in a database is same as the table in a database. Can it be the same?
It's not. It can't be the same, sir.
But because they are using the same name, they have something in common.
Yes, sir.
Beautiful. That's where I'm going there. Now, in database, the tables. So you can see a question, it also can come and tell us that describe the following in lingua relating to geodatabase. Not you'll be asked, describe the following concepts in line with database system. And you will also be asked, describe the following concepts in line with your database modeling and designing. You may flop by repeating the same thing for the two, because they have the same name, they are spelled the same way, they have the same number of characters, but they're never the same thing. So let's go further than that. Now, in a database, tables are being used. These tables are collection of rows with the same number of fields or columns. these tables contain rows. All rows. All rows in a table have the same field. That is the same thing everywhere. For all tables, in all tables, at least all rows must have the same field. That's what makes it a table. Each column has data type, source types, integer, decimal, numbers, characters, and dates. Yes. Yes. Characters and dates. So means that should in case we have a table, if you look at the examples we did in under access database modeling and programming, where we talk about books, Abi. I remember when we talk about library and books. I still remember.
Yes, sir.
Yes, sir.
The fact that under name, we can only use alphanumeric characters. At least nobody can be bearing 1, 2, 3. Have you heard of a person that's bearing 1, 2, 3?
One word, sir.
A person whose name is 1, 2, 3.
No, sir.
So that means that under name, there must be a data type that you can use for names.
Okay, yes,
Isn't
yes,
it?
yes, sir. Yes,
The
sir.
same thing goes for if you look at the table, if you look at the example that is being shown by your right hand side.
Yes, sir.
Sorry, let me go back. On the right hand side, if you look at this example here, find that on this table they call they also call sales price, Abi.
Yes,
Sales
sir.
price, Abi. So under
Yes, sir.
sales price, you expect to see numbers, integers,
Yes, sir.
Abi. You
Yes,
cannot,
sir.
you're not expect to see
Yes.
names or letters.
Letters.
You expect to see currency under sales price, Abi.
Yes, sir.
So that means that for the field for sell price, there's a typical data type that must be used.
Yes, sir.
So that's what they're saying in the third row. In the fourth row, this first bullet, now talk about that functions and operators are available to manage tables and their data elements. Now, what are they trying to say there? Is that in a database, if you are using a table, there must always be functions and operators that must be able to manage the table. Means that the table must be such that it has relationship that we can move from one point to another. That SQL commands can be executed. That's what they are saying. So if they ask you, describe a table in the lingua of the database, all these are expected for you to be, for those of you that know it, your tone of speaking or your tone of writing will actually highlight point first to the fifth, the first to the first point to the fourth point. Now, let's go off from there. If you look at, I'm coming on. Have I repeated? I think. Okay. Previous. Next. Okay. I think I have a petition here. I'll look at this and get back to you. I'll update you anyway. So let's go for next. Now, let's not talk about the data types that are being used in the database. If you look at the first 4 points that we have listed in the previous slide, they are normal for all tables in a database system. They are normal. Then definitely there must be something unique about a geodatabase. Are we together?
Are together, sir.
Yes, sir.
In the previous slide, we talk about a database, a table in a database where we measured 4 points that describe a table in the lingua of a database. However, this is also common for a table in non-ordinary database management systems, in an ordinary database. Then that means that there must be something unique that we have not actually highlighted for a geodatabase table. Yes or no? Yes or no?
Yes, sir.
So,
Yes, sir.
how do we know the uniqueness of a table in a geodatabase? Now, the uniqueness of a table in a geodatabase comes from the data types that are available in the fields of a table in a database. No, you say that every field has its own data type. Abi?
Yes, sir.
So definitely, what will make a database table unique will be in the data type. So please put in your mind that is actually where we are going. That's the uniqueness of a table in a database. And that's the uniqueness between a shapefile and a database. If you are conversant and you're an expert for your 5 years in surveying, for your length of exposure to ArcGIS, QGIS, all the GIS softwares, you'll be coming across creating shapefile. You'll be coming across creating the database. Yes or no?
Yes, sir.
Then they will now ask you what differentiates a database from a shapefile. Why a shapefile only? Okay, sir. Why a shapefile only use a normal table, just like an accountant, just like the economics, just like the social scientists? The database makes use of its own unique table. Where the uniqueness comes from is the data types that are available in the table. Now, what are data types available in the table? And where is the uniqueness in the data type? Because we have been told that the first and foremost data types in the table is numbers. Everybody knows number. Don't you know number? No one to tell it. No one to tell 1 million, even infinity. Yes or no?
Yes, sir.
You know 1 to tell it. Is there anybody here that doesn't know 1 to tell it?
Nobody.
If there is, so let us know so that we know that maybe we can just go to, is there a river? Is it Osun? River Osun? I'll go and wash your head.
Go and watch it at Unilag River.
Yeah, you that river is polluted. So for Osun, it's still fresh. You know, that river is very close to the lagoon, so it's very close to the ocean. So all the waste produced will be the waste pollution is much compared to river Osun that is coming from
That's
the
clean.
content. So you can go and watch the person said. Now, so what we're saying is that number is common for all tables as a data type. Then let's go to now another data type called text. Text is also common. We know ABC. I don't know whether there's anybody that doesn't know ABC again. So there's no, but everybody knows ABC.
Sir.
No. Now, everybody also know dates.
Yes, sir.
At least some people know dates. You cannot write dates as 1, 2, 3, 4, 5 as dates. For those of you that have actually, for those of you that are actually they were actually an expert for your 4 years in 4 to 5 years in surveying, you will not tell that doesn't know anything about GPS time. You will not tell that don't do anything about Gregorian time or Gregorian calendar. You don't tell me that doesn't know anything about time systems. UT1 is UT2. Are you telling me that you don't know anything about UTs? Universal coordinated time. Anyway, go and revise. You still have daunting years ahead of you to master your profession. Except you want to limit yourself to cadastral. Now, all I see about time, date and time is that date and time, there's a way that we ensure that date and time, and that format is being used to on the feed for date and time. Under date and time, you cannot put ABC, you cannot put November 1, 2, 3. There's what we call date can either be date only. If you look at the example of this table, on this owner table, where we have the feed or the column for date, cell dates, what can you see? You can see the format of dates there, Abi.
Yes, sir.
So these are the format. This is just date only. We also have date and time, where they'll just put the date and the time. You can also see time only, right? Because the event is happening within a time period where it don't that means that everything is happening within a day. Then what can you if you are to put dates? Because you are just going to put time there, Abi.
Yes, sir.
Because the phenomenon is time based. So those are things that we those are things that then there's a uniqueness in the field in the data type for dates. Meaning that date cannot be written as a text, date cannot be written as a number. Even Excel is designed such a way that if you write a date, it will convert it to its own native design, natural design. Have you come across that? Have you experienced that? Hello?
Yes, sir. We've experienced it, sir.
You have experienced it where you write dates you write full dates in Excel and you turn to normal date system. Have you experienced it?
Yes, sir.
So that's its own format. That's what we're saying. Then we now have what you call block, binary large objects. This is one of the uniqueness of a geodatabase. Block is a data type that's being used to store documents, photographs. Imagine, at least all of you know Google Earth and Google Earth now. You know Google Earth Pro.
Yes, sir.
And it's a business on Google Earth, and they have a picture, and you click on the picture, it will show the lateral or the close view of the business in question. Yes or no? If there's a building, it will show you the lateral the extra picture of the extra picture of the location that you click on. Yes or no?
Yes, sir.
It's being stored under blur. Blur can only accept what binary large objects to store documents, to store pictures and other media files or large data files. So those are the one of the uniqueness. For an accountant, for a social scientist, if you are used to SPSS, if you have at least you have come across SPSS now.
SPSS.
If you have not come across SPSS, you have come across Microsoft Excel.
Yes, sir.
In under Microsoft Excel, can you do things like Blur? Can you send anything like Blur?
Nothing like that, sir.
Microsoft says Microsoft Excel. You cannot under Microsoft Excel. You cannot under Microsoft Excel. There is data. Hope you know that. Under Microsoft Excel, there is text. Under Microsoft Excel, there is number, but there's no blur under Microsoft Excel. Meaning that doesn't store documents as large as photographs, pictures, videos.
Yes, sir.
Are we together? So this is one of the data type uniqueness of a geodatabase. Going further, apart from blur that makes it a unique table in your database, we also have what we call the global identifier or the global ID or guild data for types, which is used to store registry related numbers, like registry side number. Most of those are 36 characters. Meaning that, how will I say this? No book number, ISBN, International Standard Book Number. Have you guys come across it?
Yes, sir.
That
At the
if
back
we
of
just with
everything.
just a number, with that number, I can identify any book in the world. Hello?
Yes, sir.
Yes, sir.
That is
Yes,
what you
sir.
call global identifier. It's more or less what you use in geocoding. At least they are taught to geocode in your GIS.
Yes, sir.
It's one person that is saying yes, sir, yes, 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 sir. No problem. There's a quiz. Anyway, there's quiz. There's quiz. So please, that you that say yes, sir, be attentive so I can get more mark in the quiz.
Thank you, sir.
So lastly, we have what we call an object identifier. An object identifier is not unique. But is a must in all tables. Is a object identifier that's always been used as a unique number or unique integer that cannot have non-values and is added when a database table or feature is created. For those of you that are conversant with ArcGIS or GIS software, find that when you create, if you want to create attribute table, or if you create any shapefile or you share anything, and you open your attribute table, even without you not populating it, object ID will always be there.
Yes, yes, sir.
That is the data type. That is a data type that is used to uniquely identify a field or a row or an instance. It's what we call object ID. It's an automatic itself, automatic creation. It is not only unique for the database, it also happens in what you call it in any database system. Any database system that you are creating, there must be automated object identifier. If you do your assignment on access, you find that under access, once you create a table, you will see that point. There will be counting on its own. Yes or no? That table, there will be a field or a row column. Will be counting on its own. It's just to count.
Yes, sir.
So that's the way you call the object identifier. And that identifier is only numbers. It's only integers that must be there. Can never see A, can never see B, can never see 1.2. So moving further. Oh yeah, say a sheet of paper. Hello class.
Yes, sir.
Say a sheet of paper. Write your name, write your matric number. Say a sheet of paper. Write your name, write your matric number, and answer the question as displayed. You have to submit 30 minutes after the lecture. So if in 5 minutes time, I will move to the next slide.
This man, the way you look.
Are we together?
Not together, sir.
Now, let's continue our class. So, feature class are what are feature class? No, we talk about three fundamentals of a database. Abi,
Yes,
the
sir.
table, the feature class, and the raster data set. Now, we have talked about table. Now, let's go to a feature class. A feature class are what we call homogeneous collection of features, each having same special interpretation. Imagine you have manholes. At least you all know what you call manhole.
Yes, sir.
You have manholes within your school environment. And I said, please go and geolocate all the manholes in the school. They will be all points, yes or no?
Yes, sir.
So all these points together they form what we call a feature class. Now imagine not only are you geolocating manholes, you also have to go and geolocate mass, telecommunication mass. What we use to represent the telecommunication mass in GIS?
Polygon.
Polygon. They represent the telecommunication mass.
A point, sir.
Use a point.
Thank God that you're now in my shoe. You're now that what now? So
Yes, sir.
you are using a point to represent a manhole. In the same school, you are also using a point to represent a telecommunication mass. Now, what about tree? A single isolated tree. What will you use to represent a school isolated tree?
A point, sir.
A point. Now say, okay, Mr. Man, go and geolocate all the single trees, all the manholes, and all the mass, a telecommunication mass in the school. We not use point for everything.
Yes, sir.
Three of them together become what we call a feature class. So a feature class are homogeneous collection of common features.
Okay.
Maybe all the masses, all the manholes, all the single trees, each having the same special representation. That's why you will see that in our PowerPoint, you could see that we have points everywhere. But there's something that each of these points are manholes. There's something that each of these points are trees. There's something that each of these points are mass. What they just mean is that they are a feature class on their own. It can be a line, like a road. A road, you use a road for a line, or you use a line for a road, have you?
Yes, sir.
It can be a river. Use a line for a river. Yes or no?
Yes, sir.
It can be a boundary. A boundary between two parcels. You use a line for it as well, Abi?
Yes, sir.
So altogether, they got common under feature class on their own. So does not mean that that's what you see under series of lines. So does not mean that each of these lines they are the same. But because they have the same special representation, that's why we call them feature class.
Class.
Polygon. I don't need to talk much on that. The same thing with polygon. Now, each of a particular feature class has the same set of attribute column. What do we mean? We mean that they have the same table. A feature class has the same table. What mean by a table? Having rows and same number of fields. Are you reading now? Does not
Yes,
mean
sir.
that each of the records are the same. Hope you get. The record might not be the same. Like when we have a feature class for point now, when we have the manhole, the street lights, the bus stop, the trees, the decoration mass, all points. And we have a table for that all points. Meaning that all points, they must have the same numbers of columns. but different records. Is that taken now?
Yes, sir.
That's what we are saying. Can I move forward?
Let's move forward, sir.
Now, that's a feature class collection. Then what's the question now is what's a feature? Now, we have been told that a feature is an object that stores its geographic representation, which is typically a point or a line or a polygon, as one of its properties or field in the row. Does that make sense at all?
Makes sense, sir.
Good. What they are saying is that a feature, like if you get a shapefile and you open the attribute, as part of the attribute, you will see the row or the column or the field that shows that is a line, is a polygon, or is a what? Is a line, or is a what do you call it?
Rules.
Or there will be a field that will show that shapefile is either a line or a polygon or a point. Are you getting now? That's why if you want to create a shapefile, you must specify whether you are using a point or a line or a polygon. Yes or no?
Yes, sir.
Because there's always a field that must be stored with the geographic representation, be it a line, be it a point, or be it a polygon. That's what makes it a feature. So a feature is just an object that stores its geographical representation, which is a typical line, point, or polygon as one of its properties or field. So if you have a table or a database table or a database, in that database where you have a combination of houses, imagine you have a database that have houses, that have addresses, that have street lights, that have manhole, that have you also have what you call streets, it has roads, it has drainage system. In that database, you'll be able to know each features, whether the feature is a line, the feature is a polyline, the feature is a polygon, the feature is a point. Is that taken?
It's taken, sir.
So just repeat what you just repeat the idea of a certain other time. Now, we need to now know the basis of a feature class. What are the types of feature class that's possible? I've talked about the points. I've talked about the lines. I've talked about the polygons. Now, does this end there? No. We also have what we call annotations. How? What do you mean by annotations? Imagine you write points, you draw, you are supposed to produce a sheet guide. In your sheet guide, won't you not put names? Won't you not put the title?
We'll put it.
You
We'll
put them. If you export those GIS items to AutoCAD, what would they become?
A file.
Gentlemen, 2 marks for so far, 2 marks for anybody that will get this question. I'm in ArcGIS environment. I draw my load, I draw my polygon, I draw my points, and now label them. Point, line, polygon within that same ArcGIS using annotation 2 or draw 2. And now export everything and convert to CAD and send and go and open within AutoCAD. What will happen to those annotations? What will they become?
A file.
A map.
They become
A
what?
map. A map.
A map.
They become a map. They become what?
A shapefile.
A. I'm listening now.
Annotation.
They become annotation again. Hope you know that there's annotation in AutoCAD. Though. Hope you know AutoCAD has its own annotation where you can actually change and edit. I hope you know. Oh, too bad. Too fit. That means that you guys are not expert in CAD environment and GIS environment. Yeah, if
They
you
become
are,
lines and points.
it becomes what?
Points and lines.
Work on points and lines. Ah, what's your name?
Abisoye, Akinola Abisoye, sir.
Now use the message chat
Yes, sir.
to
I was going.
to indicate to actually what you call it now. That's your matric number, your name, and add 2 marks in front of your name. Ada, are you there?
Yes, sir. Yes, sir.
I've not seen the attendance. Oh, are you taking the attendance?
Yes, I'm taking it, sir.
Don't give
I'll send
me
it after the class.
numbers that are higher than what I can see in my screen. Oh.
Yes, sir.
So Akinola Abioye, add 2
Yes,
marks
sir.
for yourself.
Thank you,
So
sir.
you got is you don't got it right. Didn't got it completely. You got it halfway because when you annotate in ArcGIS and you export to CAD, they all becomes lines, not points. You can't see points. You can't see points. Even though it's point, if you put dots, in ArcGIS or in GIS environment and you export to CAD, you turn to circle.
Yes.
Are you taking now? So
Yes,
what
sir.
that means is that each annotation becomes a data type. Are we together?
Yes, sir.
Means that annotation on zone is a data type in GIS environment, in database, in Geodatabase. If you create any annotation in GIS environment, GIS will be able to know a label. No, when you are doing your sheet guide, you will tell the computer to label the lines, Abi. Tell the computer to label the polygons, Abi. You will tell the computer to label points. Yes or no? Like you want to show your department in the map of your school. Oh, and you are using a point. And how will I know that's a department? Won't you label the point?
Label it, sir.
You label the point. But how do you know label? If the computer, if you can either use annotation to write the name, Abi, or you can either tell the computer to actually label the point by itself, Abi.
Yes, sir.
Yes, sir. Now, when you how do you not differentiate a computer label and a manual label? Is two annotation data type. If it's computer label, it will not be a data type on its own. It will just be an attribute of that line. But if you use annotation, it's a data type on its own, different from a label. Are you together? Are we together?
That's together, sir.
Am I making sense?
You're making sense, sir.
Yes,
So
sir.
that is what annotation data type is all about. Because you'll be asked, what is the type of feature class you know? At least give us 6. So for those that I think that is just line, point, and polygon. Or you're there, wow. You haven't done that too. Is that taken?
Yes, sir.
Yes, sir.
So the annotation on their own. Are data type or they are type of feature class, because if you are used to ArcGIS Pro and you try to label manually using the drawing tool, annotation tool, you will find that it will create a separate layer At least you know layer now. That's a table of contents. Abi? Hello, class. Have you done my assignment for with ArcGIS Pro? Wait, is this class boring? Is it boring? Is it boring? Is the class boring?
No, sir, it's very interesting.
Let me know
No,
if
sir.
class is boring, you know.
It's interesting,
Sir,
sir.
no,
If
sir,
you
the
are-
class is not boring, but it's just that the assignment is fearing us.
Do the assignment, oh, it's for you. Oh. Seriously, I can tell you. The best I can do it is now. So do the assignment. Now, what we are saying, if you do the assignment, find out if you are labeling in ArcGIS Pro, it will create another layer under your table of contents, and you could call it graphics. That graphics on its own becomes a data type. That's what that's what we are saying. Going further, we also have what we call another data type called dimensions. This dimension, you guys know dimension already, because in AutoCAD you can put dimensions, Abi.
Yes, sir.
Now in GIS you also put dimensions. Dimensions are now another data type on their own. They are different from annotations. They will be separated if you are exporting them, if you are creating them. So and that's so you cannot say, okay, if you are putting dimensions, so everything that everything that you have to label, you can using dimensions. They will be grouped as dimension. So they are a feature class on their own. The same thing goes to what we call multi-points. Multi-points. Imagine you are trying to tell us that there are different land uses for a spatial, for a scattered, or for a sparse vegetation where we have trees everywhere and this everywhere, and everything together is just one feature. We usually call multi-points. So multi-points is a type of feature class. It's a polygon of what? A polygon of points. That's what we call it, multi-point. A polygon of points. So it's different from points and it's different from polygon. When polygons and points are being used to represent a particular feature, then it becomes a under what we call feature class. Then apart from that, we also have what we call multi-patch. Multi-patch is a union between polylines and polygons. You know, when we have point and polygon, we have multi-points. When we have lines and polygon, we have what we call multi-patch. How do we come across multi-patch? Imagine a building face of a building. In that building, there are so many lines. The face of that building is made up of what? It's made up of, okay, let me not use that. Let me use a rock. For a rock, within a particular face of a rock, there are different lines. Abi? Different lines. Yes or no? Yes or no?
Yes, sir.
So when you now combine those lines and the entire boundary of the rock, you form what we call a multi-patch. It's another on its own. They also have 3D objects. 3D objects is when you are doing 3D graphics. So 3D objects are a kind of feature class on their own. Those are the major feature class that are available in ArcGIS in Geodatabase. So on this note, I will conclude the class for today. Should in case you have more time, we can go further and do to next week class, because our last class is in lab. I'm going to show you the lab. I'm going to practice something for you. Then you are going to now do assignment and submit. Next week we conclude our class next week. And any question? Any question?
Yes, sir. We can't remember the assignment on the ArcGIS Pro, sir.
Okay. I sent two zip file on the group. In
Okay,
that
sir.
2 zip file, I will reply and tell you those assignments on ArcGIS Pro.
All right, sir.
So
Thank you, sir.
you have to submit them. So your next assignment that you are going to go to your submitting next week is for you to compare and contrast between types of geodatabases. At least you know the database now. And I've told you to database. So you have to go and revise the lecture material and give us a minimum of two-page essay or report on the comparison of types of database. I've told you to write a two-page report on what is your database. And for those of you that have done it, this class will seem so enjoyable. For those of you that have not done it, some things may seem like out of this world. So congratulations, everybody. Please submit my
Sir,
assignment.
please, I have a
next class.
question.
I have a
Oh,
question.
go ahead.
It's relating to the material. This material, please, are you going to send it to the group?
I'm going to send it to the class. Are you sure now? You know,
Okay.
they say even there are other materials I'm going to send against next class. Because next class we'll be looking at SQL and database. How they relate? What's the relationship between SQL and the database? We are going to do that, or we are going to review that next class. And if you still have time, you can actually do the class now. If not, we move to next class. Ada, what do you say?
Next class, sir.
Next class. So my next class will
Yes,
be on
sir.
Monday and Tuesday. I'll be having you Monday and Tuesday. So pay time for me. 1 hour each. What is that? Talk now. If there's anything I have to watch out for.
Sir, we may
Yes.
not be available on Monday because we are supposed to submit our project report by Monday. So I don't
Okay.
know, our supervisors may want to see us
No problem.
on Monday.
So
And we have
we have. I can't hear you. Who's talking?
And we also have test on Monday.
You sure about us on Monday? So
Yes, sir.
Ada, give me 2 days. Just give me 2 days out of next week. And let me know on time. Then let me be the one to call you. If I call you, minus 2 marks.
Okay, sir.
If I call you, minus 2 marks. No, I'm recording the class and I have my record. Oh, any other question?
Nope.
No, Abby.
Yes, sir. No, sir.
So 30 minutes after the end of the class, I'll be expecting you to submit my quiz. And if I said time up, anything that comes after that will be disregarded. Because you know we have done two quizzes, and you guys and I've said time up, and people are still sending. Even till next day, some people are still sending. I don't know who want to mark those ones that I send after that. I want to see time up. Just save your time. Just save yourself and go and be doing other things. Is that taking? Is that taking?
Yes, sir.
So at that I've said, I just submitted report. I told you, the only place I can help you, is not in the exam, is in the assignment and the quiz I'm giving you. From the assignment and the quiz I'm giving you, that's the only place I can help you. And if you fail to do the assignment and the quiz, I can't help you. The exam will be you and your God. So, good day, everyone. If there's no questions, have a nice time.
Sir, will you give us AOC for the exam?
I will do that. Why not? Yeah, the AOC is simple now. It's even the AOC is whatever I've taught you. What matter I've given you, that's the AOC. So if you didn't come to class, you can't pass. That's just the truth. If you are in the class, you are sure to get at least 75%. But if you are not in the class, there is no magic. Even though Ada help you, Ada go and put your name in the attendance, you're on your own. Because the question will be applicative questions. You will see it now. You will see it now. You will see it. So if you are not in the class, there's no magic you can do. You cannot even get 2%. I'll make sure of it. So bye bye. No other question, Abi?
No, sir.
Your shame will reflect in class.
Thank you.